Good morning, ladies and gentlemen. Welcome to this panel discussion on harmonic distortion and power quality. So I would like to just brief about NFE. Who is NFE? National Federation of Engineers for Electrical Safety. And our objective is creating awareness on electrical safety. And vision is to make every electrical installation free of electrical accidents and electrocution and fire due to short circuit. So that's our vision, and mission is we shall strive to achieve our vision through getting accredited for products. Again, I would like to emphasize on this very strong statement. Getting accredited for products and personal certification, which shall focus on electrical safety by design, manufacturing, installation and maintenance of electrical product, and installation by competent. Again, I would like to say what is NFE's mission is to ensure that we have a competent engineers for installation and quality manpower for using quality resources, including product, process, and procedures. What are we doing today? We are doing creating awareness on electrical safety, improve skills of practicing electrical engineers, improve safety measures followed in the industry, introduce modern safety measures such as National Electrical Code of India, CEA, and improve quality of electrical installation. That's the clear mission and vision of NFE. In yesterday's program, after we completed, we have to finish it at 5:30, and so nice to see that Chennai National Electrical Code of India, entire 160 people stayed back till the end. And once we all dispersed, a couple of people came and asked, I could see so many passionate speakers talking about it, like Appavu sir, who's retired director, inspector, in his retired chief electrical inspector. Even after retirement, he's contributing. So they're asking, what are you guys getting out of all this? I can see Gopakumar sir, everybody. I said, are you getting paid for all this? I said, no, sir. It is a passion to make electrically safe because it's an individual choice. So we are just traveling all the way and spending our valuable time, though we all have our businesses. So a lot of people keep asking the way we conduct our programs. You can see the webinar. Yesterday we completed a seminar and today we have a webinar. It's a continuous process. So it's like running as if there's no tomorrow. So I would urge everyone who's joined us, and most of them are members of NFE. Those who are not, kindly become a member of NFE. If you go to visit our website, you can find the menu there. I would urge all the companies to become a corporate member. You have a lot of advantage being a corporate member. If you're a standalone engineer, if you're doing audit, okay, you can choose an individual member. But those who are promoting products, have a solution or a contractor, I would urge them to become a corporate member. And we also have an option of MSME for this. And from January, if you see, we have been doing continuously webinar. We have done Earth Electrode, very well received. We have completed on January 4th. Then we did our Nagpur, a one-day workshop, very successfully conducted, again, houseful show. Then we did CA regulation on electrical safety on fault loop impedance. So it was also well received, supported by Fluke. And we did a CA regulation. Appavu sir conducted this webinar on 27 January. And last week we did a seminar, a workshop, a full day workshop in Vadodara. Again, it is a houseful, no place for the people who came late. It was a well received workshop in Vadodara, and we did last Saturday on power quality and harmonic distortion by Hari Balasubramanian. So very well received, very well appreciated. The kind of question that was coming, our President Gopakumar and General Secretary Appavu sir thought, let's continue next Saturday with open question answer, have a panel discussion. That's how we are all here today, to continue what we left on last Saturday. And just to remind you everyone, we did our workshop yesterday in Chennai, Radha region. We had 160 participants. It's very encouraging wherever we are going, and we are getting houseful. All this happening because we have a wonderful supporters. Okay, BIS has been partnering with us, and International Copper, and we have wonderful sponsors like Polycab, Cape. We have Sonel coming in. We have Fluke coming in. Uh, I'm expecting if you are into a manufacturing, please join us because we need good resources to go around the country and do it. So the more the sponsors come in, we have a breathing time to conduct many more workshops like this and many more webinars. And we upcoming event on the next Friday we are doing in Goa. Those who have some presence in Goa, please do join us in Goa. We will be sending out the invite. That is on 23rd from 9:30 to 5 p.m. Then followed by Mumbai. We are doing in March on 15th in we have the hotel has been confirmed. I'm not getting the name now. Anyway, Koinur Continental.
Kohinoor
Sorry,
International.
it's a
Kohinoor
Koinur
International.
Continental in Andheri East. We also celebrating the 1 year of celebration. We don't know how this 1 year we went, and if you look at 1 year, books are not enough for us to write. The kind of programs that we did. Uh, Literally every week we have a program, every day we have a program. So we'll be celebrating our first year in Mumbai at 6 o'clock. I would urge again all the corporate members to come in, support us. Our motivation, inspiration comes from people who continue to support us. Kind words that you give, it inspires us. So I would urge to please to come in. So let's come to the subject today. It's all about harmonic distortion and power quality. We have wonderful panelists today. I will just introduce them, and the reason why we are here. And this is a small explanation why we are here. And myself, Dominic, I've been in the fire industry for 35 years. We have our moderator, Gopakumar, who is a well-known face in the country, who's been, again, running length and breadth of the country and talking about and writing codes and understanding better codes of the international codes. And we have we are very honored to have Apau sir as General Secretary, who's been mentoring us, who's motivating us in spite of his retirement. And not normally everybody sits at home, but he is again traveling with us, talking hours together in the workshops and seminars. And we are so happy to have Hari Balasubramaniam, who joined us last Saturday. And he comes with wealth of experience, 30 years of experience in both India and Middle East, and a wonderful speaker. We are really excited to hear him. And I'm very happy that he also joined as a member of NFE, and I'm sure his company also become corporate member and continue to support our mission. And we have, hope he has joined, Mahendra Chilkuri, and who is from VIT, Vellore, and he also got a fantastic experience and very well qualified. He's an associate professor at Vellore Institute of Technology. He's also focusing on power system and smart grid. So I'm sure he has joined and he will also share his experience. We have Ravichandran Krishnaswamy. Ravi is also known electrical engineer and power quality specialist with over 3 decades of expertise in India and Middle East. So he's a founder of Fortech Engineer, Fortech Electric India Private Limited. So a lot of innovation in his companies and the product solution that he's offering. And he's notable for his design of passive harmonic filter. So I'm sure you'll also continue to support us as a corporate member and also participate in our various workshops. So we have next panelist Ronak Desai from Mumbai has joined us from Vision Power Analytics. Again, he also took active role in last Saturdays. Wonderful experience of 15 years. He's commissioned significant project and presented power quality case studies globally. Certified by B as an energy auditor. He leads technical development, sales, and advocating electrical safety through awareness program, overseeing the team of dedicated to safety, protection, and reliability. I'm sure Ronak will join, strengthen NFE with his experience and your field experience. We need people like Ronak Desai, young gentlemen are coming forward. So we need soldiers like him. We need commanders like Apav sir to lead us to better future, better electrically safe nation. So with over this, I would like welcome our moderator, Mr. Gopakumar, to take over, and I would request all the participants to please post your questions for moderator to pick up from the Q&A box. There is a Q&A box, you can put your question, and our moderator also will invite you to come on live to discuss and all that. Please do not post your questions in chat box. Chat box, we cannot record it. If you put it in Q&A, we can record it. So let's make this, the day very fruitful, great learning. Over to you, sir. Gokumar, sir. Welcome to you, sir.
Thank you very much. Thank you very much, Mr. Dominic. It was a detailed introduction. Out of the whole panelists, I think I am the only person who doesn't know anything about harmonics. My knowledge on harmonics and this subject is quite very narrow. So it will be good that I can ask question like a person who doesn't know about the subject, so that the answers will be more clear to the audience. To start with, we have the very well experienced panelist today. To start with, I will start the question with Dr. Chilikuri. Dr. Chilikuri, you have to unmute, and I hope your voice would be clear. You were putting a chat. Can you unmute yourself and check the mic? On the bottom of the screen, there will be, on the left side, there will be a mute, unmute. You have to unmute yourself. Okay. I think there is a small issue with the unmuting the system. Probably it would be good if you disconnect.
Can you hear me?
Yeah. Now it is clear. Now you
1 minute.
audio.
Actually, the window also.
Yeah, thank you very much, Dr. Chilikuri.
Okay.
The first question, let me start with the first question.
Good morning.
I would say that there will be two rounds of questions. So the specialty of electrical engineers are, once when we start answering, it becomes a non-stop answer. So this I would like to restrict for certain time, probably maybe 3 minutes for each question. Otherwise, it becomes a little bit difficult for us to control. So the first question, harmonics is the current standard and the super harmonics will become the future standard. Can you throw some light on this subject?
Okay, good morning, everyone. First of all, I'd like to thank NFE for inviting me to join this panel session on power quality. And as the topic mentions, power quality harmonics, we have to look what is that new problems that is surfacing, and then we have to work towards developing some revision of the standards so that we can understand the current environment better. So if you look at in the last 10 years, the use of LEDs has grown. Okay, not only use of LEDs, that power electronics technology actually it changed very much with the IGBTs coming into place. The switching frequency has actually increased from 2 kilohertz to more than 10 kilohertz. So I would like to mention supraharmonics is nothing but it's an extension of harmonics, but well beyond the 2.5 kilohertz that we are currently trying to measure using the existing equipment. Most of the equipment actually they are designed to measure THD of voltage and current for up to 50th harmonic. Okay, and only very few new equipments under Fluke and also in the PQ box, they incorporated the new measurement for supraharmonic, which is up to 150 kilohertz. So the reason is some of the equipment like LEDs and electric vehicles and some LCD TVs and solar inverters, these are all emitting frequency well beyond 10 kilohertz. In fact, just now before joining this meeting, I was referring one paper which was published in Industrial Application Society of IEEE in 2020. It shows that if you are measuring harmonics up to 2 kilohertz, it shows very low value, 1.8%. So you think that the THD is well within the limit. But when they measured in two bands after the 2 kilohertz, like 2 to 10 kilohertz, 10 to 150, 10 to maybe 60 kilohertz, and 60 kilohertz to 150 kilohertz, they found additional harmonics and higher harmonics, and THD actually increased it to 8%. So, because of the limitations on the measurement system, and we are not able to capture the current, harmonic footprint. So, the supraharmonic is nothing but the frequency which is between 2.5 kilohertz to 150 kilohertz. And so what I would like to say is that not only we should have a measuring instrument that can measure up to 150 kilohertz, but also compute THD based on that formula. So if you see IEEE standard or IEC standard, still the VTHD and ITHD are computed up to 2.5 kilohertz or 50th harmonic only. So the computation of the VTHD and ITHD will be inaccurate because some of the equipment are emitting frequency which is more than 10 kilohertz. And not every equipment is emitting more than 100 kilohertz, but less than 100 kilohertz, but up to 10 kilohertz. So, in fact, for BIS working group on ETD01, I suggested that we should investigate that EV integration into the residential and commercial and industrial supply through investigation, whether any emission is coming through EV, especially in that particular 2.5 to 150 kilohertz. Because EV, again, many utilities are actually using a different type of charging system. Some of them are using DC, some of them are AC, some of them are using fast charging system. So there is two type of problem that will come through this supraharmonic. One is called primary emission and secondary emission. Primary emission means a single device emits a supraharmonic, whether it will have effect on any components of any electronic in the router or any electronic device. Second thing is, if you have two devices, there will be an interaction between the device 1 and 2, and that may create a problem in this distribution system, especially LV distribution system. So perhaps I just want to highlight and give some references for the further details on this topic so that the audience can, refer the information in detail on their own.
Thank you. I hope I can. Next question. The next question is to Mr. Haribala. Mr. Hari, what is the difference between THD, total harmonic distortion, and TDD, total demand distortion?
Total demand distortion is the word coined out of IEEE 519. This is specifically for the current. So I would like to explain by sharing my screen for 1 minute so that it would be helpful in understanding that. I will share it. You're able to see my screen? I will.
Yes. Yes. Make it full screen.
Yes, I will make it full screen with the stuff what I wanted to show. Okay. Yes. See, here there is a total harmonic distortions formula is given. It is based out of the fundamental waveform. So it calculates out of the 50 hertz waveform, and then it calculates the sum of all the individual harmonics up to whatever the way it is calculated. As Professor Chilkuri said, that the THD should be calculated for a more number of frequencies included. So here, assuming that we calculate up to 50th harmonic itself, in this case, if you see the current, when the current goes high, the THD is low, and when the current is low, THD is increasing. Yeah, so it's in the increasing trend. So when you are calculating THD, it is always inversely proportional to the load predominantly. Yeah, so if a VFD, in other words, is loaded less, the total harmonic current emitted can be higher. And if the load is gaining momentum and fully loaded in the same VFD, then we can see the total harmonic distortion emitted is lower. When it comes to the total demand distortion, it is based on the nominal load or the nominal load in the system over a period of time. So if, for example, IL is called as the maximum average current in the last 12 months period. So you take the average of how you have used the system and then calculate the total demand distortion. With the same way, here you use IL as a value. In THD, you use fundamental as a value for calculating on the denominator. So which means whenever your load increases, your TDD will also increase. Whenever your load reduces, the TDD will also reduce. So you can see it on this very clearly on this particular graph. Now, I will also compare how the THD and TDD behaves. So TDD goes according to the load, and THD is more or less inversely proportional to the loads. So this is how it is there. So we should also consider THD and also consider TDD at a point how to do the mitigation. And the experts would also say how we can, whether we should mitigate for TDD or THD is also another question. I will pose it and then I will leave it as it is here. I hope this is understood clearly.
Yes, thank you. Thank you very much. Probably I will go to the next question. Next question is to Apav sir. Also, for the information of participants, if you have any question, please post your questions on the Q&A box so that all the panelists can look into the question and try to prepare the answers. Now, to Apav sir, sir, what is PCC and what is the role of ISC and IL in arriving an effective methodology for implementation by the DISCOM?
Good morning, everybody. It's a very valid thing because ultimately people are bothered about the mitigation against the statutory implementation. So here comes two important parameters. So that is ISC, I short circuit, which is based on the fault level at which the consumer is fed from the substation, from the distribution substation or the public utility substations. Another thing is the IL. Haribala has already explained annual average demand level. So these two things are totally changing the scenario of implementation and mitigation. The mitigation is two parts. One is for compliance with the suppliers, that is implementers, regulatory norms. Another thing within the plant. I'm not touching upon the thing within the plant, but this is a compulsion. There should be complied as per regulatory commission's orders by the DISCOM. Here, what happens is the ISC, that is the fault level itself, is not known to the consumer. I don't know why this is kept as a secret, because not only the power quality, it is related to the design of substation on fault level, etc. So the fault level should be transparently available to all the consumers. That is what I can say. Based on which only everything the consumer can assess what is his. He knows his annual demand load, but he doesn't know the ISC. But ultimately, you can show the table 3, Mr. Gopa. Table 2 of IEEE 519 shows, for example, it shows that from 120 volt to less than 16 kV, the TDD limit. TDD is nothing but THD into I1, that is IRMS. IRMS is the current during the period of testing. And denominator
I
is...
hope, sir, the screen is visible? Or I didn't share. Okay, sorry. Now I think the screen is visible.
Okay, in the screen you can see that what is TDD permissible is related to the first column is ISC by IL. For less than 20, yes, for less than 20, if the ratio ISC by IL is less than 20, the TDD can be 5%. It should be strict. You have to limit your TDD less than 5%. If it is more than 20 and up to 50, you can pollute more because the grid is strong. It can be up to 8%. So it goes on. So in short, the ISC by IL is the factor which poses a threat to the consumer. are what do you call the basis for the consumer to arrive at what he has to do to contain his limits. In short, if there is a strong grid, you can pollute more. If there is a weak grid, you are totally restricted. You can't pollute. So the thing is, the grid is not exhibiting a constant short circuit level. It can be offer a very high short circuit level at the industrial areas, IT sector areas, and city centers. But in rural areas for the same developing industrial premises, it will be weak. There are grid exhibiting 10,000 MVA fault level at city center and 1,000 MVA fault level at the rural centers. The thing is, you can't have a constant ISC anywhere, but the consumer has no choice how to have this ISC. So what the implementers, they arrive a common methodology to avoid any grid growth differences in ISC and the calculation and cumbersome process of arriving at the TDD level. They declare simply an average value. For example, instead of 10,000 and 1,000, if they declare 6,000, then most of the consumers will be escaping. So ultimately, in addition to the non-linear loads even in the domestic EV and solar, the industrial premises which is already polluting more will be given a concession. That is what I can say. So in order to mitigate the harmonics, the ISC should be taken into account. Another thing, there are certain situations where the consumers can't have what do you call? There are some situations where the preceding 1 year period for the 6 months consumer might have a low consumption. He could have surrendered. For example, it could be marketing or production failures or some other demand-driven or some pandemic or some other educational institutions due to lean hours, lean period. So the IL could be less. If the IL is less for the same THD, for example, 10% THD for the same THD, if the IL is very low, it will be escalated as 10% TDD. Suppose if your IL is high, it will be reduced as 8%. So the compliance is also depending on the ISC. So the consumer should be shrewd enough to manage his demand and know the ISC. The implementer should also be shrewd enough to fix at the level of ISC to have a correct implementer. That's my opinion.
Thank you, sir. Thank you, sir. I also request the panelists to go through the Q&A. If you click Q&A, you will be able to see the Q&A in the panel. Probably if you can answer, type the answer and post it. So the question will be answered, plus everybody can read the question as well as the answer. Now the question is to Mr. Ravichandran. THD current tends to be higher at lower load and low at higher load. In light of this variability, how can we design the filters effectively? Mr. Ravichandran? I hope.
Good morning, everyone.
Yes.
Thanks to NFE for giving the wonderful opportunity, which is, sharing of knowledge. Because of power quality, every day we are learning. So from the participants, definitely we are expecting more questions because of from their question only we are, every day there is a possibility of learning the things.
Which was generated.
These are the opportunities to learn. I will share my screen. Just is it, Mr. Gopakumar? Can you allow me to share my screen?
Yeah, you can share. You can share now.
Is it possible to view my screen?
Yes. If you make it a little bit bigger, would be good.
Yeah. See, this is the simple calculator. I made it to explain simply. See, for example, 100 kVA load, 10% TST may be there. And for the same 100 kVA load, I'm deleting this. Some occasion, 250 also you can see the TSTI. See, this RMS current is the same, but I fundamental it differs. Absolute harmonic current from that, see this 100 kVA load, 250% TSTI, the absolute harmonic current is 4.87 amperes. On the other hand, if it is 10% TSTI, it is only 0.52 ampere absolute current. Okay, from this perspective, we can see that, right, this, yeah. When the distortion is high, there is no possibility of adding more load because of the fundamental current it is increasing, but RMS it is same. So from this fundamental value only we have to start from that. Before that, I think resonance frequency has to be calculated. What is our system basic resonance frequency? So this is the indicator, or otherwise, by seeing this, only by seeing this, no one should worry. Because of, for example, for connecting the computer, maybe 2 ampere may be loaded and 80% or 90% TST will be there. So this is negligible. So by seeing 90% TST, no need of any, panic, and it is, we should not think that it is high TST. But by seeing the fundamental current, it is very, very negligible. So this is the where we have to understand from the TST and the RMS current and fundamental current, we have to find the absolute harmonic current here. So from there only we have to start the design of filter. Secondly, the design of filter is important here, the individual harmonic component. What is the individual harmonic component from the measurement? Because of most of the industry, since we are using 6-pulse converter, 5th and 7th will be predominant. So individual what is the individual component of 250 hertz frequency, and the 7th may be there. There we have to identify what is the individual frequency of 7th. So this is the starting point. First is resonance frequency. We have to understand whether we are connecting the load or not. This is not a matter. Only by having that, the system resonance frequency, naturally it is created within the design with the transformer and the capacitor and the available short circuit level at the LV point. So these 3 parameters are enough to calculate the system resonance frequency. So from that, we have to find the resonance frequency. And if there is harmonic, we have to find the absolute harmonic current value here, like this. Then after, we have to identify which order it is predominant. This is the key points for designing the filters.
Thank you. Thank you very much, Mr. Ravichandran. We have Mr. Ronak Desai. Mr. Ronak, the next question is to you. Probably, Ravichandran, if you can, Mr. Ravichandran, if you can unshare the, yeah, thank you very much. Mr. Ronak, what should be the comprehensive approach for harmonics and power quality study in complex power distribution? For example, refineries, linear or non-linear loads in refineries. You have to unmute yourself.
Yes, thank you, sir, and thank you, NFE. Hope am I audible clearly?
Yes.
Yeah. So thank you, NFE, for setting up this platform for the panel discussion on the most important and growing topic actually in India in this complex power distribution system, which is now day by day we are experiencing a lot of issues. And since my background is from the end user, actually end user of non-electronics equipment, worked in industry for more than 10 years, so face lots of power quality issues during the commissioning stage of the projects. And from that time, we have faced major issues at the even medium voltage drive and the low voltage drive, how those nonlinear loads can create small issues. But the here I would share my experience and learnings about the approach. So basically, like I would start with one story, right? First of all, power quality is a subject of the symptoms. Actually, if you see practically, then what are the symptoms when we use any equipment or when we are running the power distribution? So in a complex power distribution in day-to-day operations, like say in refinery or in steel industries, where we use the large VFDs even at the medium voltage and large number of VFDs at the low voltage side. So a few cases which I can explain here is that continuous and abnormal noise observed even in the transformer at 220 kV, right? And the rating of the transformer around 750 MVA, and higher neutral to ground voltage at the low voltage main panel, and abnormal sound in main PCC panel and the bus duct riser. So these are all the many issues which I am sure many of our participants here and they have also faced such issues in the plant or maybe in the operations. So the approach to address all these issues, that understanding of the electrical network, that is the first step, which is very important. Because nowadays when we go to conduct any power quality study measurements, first thing we don't find, I mean, is the updated single line diagram, which is absolutely not updated in majority of the cases. And even if we get that, then you should have a bifurcation of that. Okay, what is the grouping of the linear load, non-linear loads? And based on that, wherever you are facing the issue, like in this case what I mentioned about the transformer, so transformer was feeding the large VFD, so there is a high probability that this large VFD harmonics emission could be the cause of the resonance, and that was creating some continuous noise, abnormal noise at the transformer level or at the bus level. Also, one important aspect, we have expert in this panel about this harmonic filter and the PF compensation. So presence of PF compensation in the network, at what position the power factor is compensated, whether passive filter, if it is passive filter is installed, then where it is installed. So these are all the things we have to take care. And power quality measurements has to be planned depending upon the objective of the issue. Say example, if we are identifying the issue at the equipment level, then our full focus should be on the measurement towards the equipment and go to upward towards the source side. But when we are doing the measurement for the baseline creation or the compliance creation, then point of common coupling measurement, and then approach towards the downstream, and then step by step we can go towards the end of the equipment. So this approach always can be preferable. So during the investigation, the key points which we found out, that transformer connected in parallel, which feeding the loads and high probability of resonance, that is due to the MV drives. But so similar noise was not observed where there was no drive. So it was concluded that okay, there are some issues because of this MV drive, and that is creating the problems. Probably I will show you some waveform measurements that how we found out even notches also from the drives. Now these notches again creates lots of issues, especially in the IGCT type of VFD, which is called the integrated gate commutated thyristor based VFDs. So these notches, presence of notches, and nowadays we have power quality monitoring expert also available in the panel. So in nowadays we have many advanced PQ analyzers which can even measure notches also. So all these are very significant issues we found out even at the 220 kV level or at the 33 kV level. And in that case, also we have to measure the complete spectrum of the harmonics generated by the VFD, and that spectrum we have to compare with the data given by the OEM. So the overall approach which normally I follow, or what I have learned from the various cases, is that 5W approach. Now this 5W approach is, you have to answer the 5 questions: that what, where, when, how, and why. So what measurements we have to carry out, where we have to carry out, when we have to carry out. When I say when, that means now in which scenario you have to carry out. So operation also, understanding of operation. When any expert goes for the power quality study and analysis, the understanding and know-how of the operations of that particular facility also plays a very significant role. And why? This is the main question, that first you establish the objective. So by answering this 5W approach, we can carry out the systematic way with a nice approach for industry. I mean, complex power distribution system we can carry out. Another aspects, what we found out, say power quality is a very comprehensive subject. I mean, but mostly in India we consider harmonics only, and this is the truth. I mean, harmonics only as a power quality. But we have seen in this typical case in refinery and the steel industry, that grounding and wiring related PQ problems, and like problems like loose connections and faulty breakers and neutral to ground reversal. I mean, these are all the wiring related issues, and high impedance neutral to ground bonding for the transformer. So this can create voltage drop, voltage fluctuation. So in totality, the inspection has to be carried out. So wiring also plays a very significant role. In my next case study, in the next question, I will show the typical case study of the AFE drive, how that has created resonance. So I will create that. I mean, I will explain in the next question. Thank you.
Thank you, Mr. Ronak. Actually, this time I tried to make it within 3 minutes, but all of you crossed the 3 minutes. But so there were some freedom, but this freedom may not be there in the next question. Sorry for that. Now we have actually a question in the chat box. Let me take, because nobody answered so far. Mostly with PCs and analytical instruments such as use SMPS causes third harmonics and thereby electronic card failure and the neutral to ground voltage increases. How to mitigate it from installation stage is a question from Mr. Subodh Bide. And in the last webinar, Mr. Hari told that the harmonics is like a garbage which is not necessary in the system. So here the question is how to avoid this garbage in the system. Also, my question probably Dr. Shiliguri can answer. What are the measurement requirements at renewable energy plants? Also, it would be great if you answer the question from Mr. Subodh Bide. You have to unmute, sir.
1 minute. Thank you very much for the question. Let me share my screen. I want to show you something related to my previous answer and also try to answer the current question. So, can everybody see my screen?
Yes.
Yes. Nice building.
Is that visible?
Yeah.
Yeah.
Okay, so I will just share that the paper that I mentioned, and where perhaps it will answer many of the questions for the audience. You can see here what the manufacturers don't tell about active harmonic mitigation. That is the first thing, okay? Especially the people who are suggesting active filter, okay? And second thing is that related to the harmonic measurement, I would like to highlight one point here. You can see here what the IEC 610032, it's about harmonic measure up to 2 kilohertz, and IEC 618003 is from 150 kilohertz to 1 megahertz. But the missing band is this. So this is where the supraharmonics is coming there. and both IEC is working and IEEE is also maybe working. We do not know. And from Indian perspective, we also need to look at this particular band and then try to, BIS only launched the 18475 PQ monitoring standard this November 2023. I think that needs a revision of THD calculation and also address this particular band. And perhaps NFE and other people can take up this issue. And one more point I would like to highlight before I answer the question. Here you can see this is the current waveform observed from the modern television. You can see if the THD is measured up to only 2 kilohertz, there is a very small THD. Okay. But if the THD is measured between 9 to 150 kilohertz, you can see this. That is mentioned in one table. And I will show you the table also so that people understand the measurement, inaccuracy. Yeah, you can see here. If you are 50 up to 50th harmonic, THD is coming 1.68. But if you are measuring with a new instrument which can measure up to 50 kilohertz, example, Fluke has 17 PQ 1775 or 772, it can measure up to 50 kilohertz. Then the THD it can show is 8.38. Okay. But if you are measuring another instrument which is up to 50 to 10 kilohertz, then you have 8 point. So there is a variation in the accuracy of the instrument based on what is the latest algorithm they are using. Now the question that is about what is the PQ measurement that we need to consider at renewable energy plants, right? So let me answer that question. I need to go to my desktop for that. And then, yeah, I want to share one of the things that we have presented to CEA. So you can see my presentation for CEA. We noticed that a lot of inverter duty transformer failures, okay, but very few people are interested to share the details of such failure. And if the failure is only one isolation case, it's not an issue. In fact, that is with one case where we have this data, and this is occurred at a plant which is 5 years old, and perhaps the one reason could be the solar plant is actually generating more than 200 megawatt. It is designed for 200, but it's generating more than 200, and it's overloaded continuously. So they have tried to provide external cooling. So many reasons could be there for this kind of failure. But at one solar park in Kurnool, at one particular site, there are multiple failures of IET within the first year, which, nobody knows what is the reason. Even that the utility try to investigate with the power quality monitoring equipment supplier, but they are not able to find the solution. So here there is a need for, and there are places where there is a cable failure is happening. This is in south of Tamil Nadu. And what I would like to show is one table here. When we investigated this study, you can see this table. We went to investigate the inverter duty transformer failures. Can you see this?
Sorry to interrupt you. Yeah, sorry to interrupt you. Our answer time is 3 minutes. It would be great if you can finish
okay.
quickly.
Yeah. So here what I would like to say is when we investigated the issue at 10 to 12 plants, we found not only that inverter duty transformer, but we have VCB failures, IGBT failures in the inverter. Many things are happening. So, and there is no provision for proper PQ monitoring. So our suggestion is that, power quality not to be monitored only at PCC, but inside the plant. And most of the failures are happening due to the transient. So transient measurement is very, very important that I would like to highlight in this particular discussion.
Thank you. Thank you, sir. Thank you very much. Now, my next question is to Mr. Haribala. How long should we take measurements from IEEE 519 compliance? Duration. You have to unmute, Mr. Hari.
Yes. IEEE 519 suggests 3 kinds of tests on a weekly basis and daily basis. So on a daily basis, we need to take data every 3 seconds. That is for all the harmonics and THD and TDD values, we need to consider for every 3 seconds. And for a weekly value, data, we need to consider for every 10 minutes the same parameters. So which means the measuring equipment should be able to handle data for 3 seconds as well as 10 minutes data. And then from there, you do the statistical evaluation. It is very clearly explained the limits for each of these tests, which is done at statistical evaluation for the 3 seconds value and 10 minutes value at 95 and 99 percentile, or limits are all different. So we need to follow the standard accordingly. So if we go through the standard, we will be able to know that there are 3 kinds of statistical evaluation which is being done, which means there is 3 statistical evaluation and 3 different limits which we need to comply with. So for 1 day and for 1 week. So it is always better we do a minimum of 1 week study in all these to do all the 3 statistical evaluation. That's it from my side.
Thank you, Mr. Hari. The next question is to Mr. Ravichandran. But before going to the question, actually, I asked that question. There was a question in the by Mr. Subodh Bide. How can we control the emission of these devices such as the LED lights or SMPS power supplies and so on? I think the simple answer is you should buy good quality, which is not producing this garbage. Garbage in the sense, garbage is the harmonics. So your product which we are buying, we have to spend a little bit more money and we have to buy good quality things so that the amount of harmonic itself is limited. I hope this answers. Is it correct, Mr. Hari?
Correct. Well, one way is doing it as nipping it at the budding stage of harmonic. So it's better you choose the right equipment which throws less amount of different kinds of frequencies, and probably second level is to go in for some kind of a mitigation closer to it. So that's how we will have to do it.
Thank you. The question to Mr. Ravichandran: how to calculate resonance frequency for capacitors?
My screen is viewable.
Yeah.
Okay. See, for the resonance frequency, I suggest to find the short circuit level available ISC from the source actually. Generally, it is calculated based on the transformer installed capacity MVA. But most probably, whenever I am doing the audit, that is misleading because of the source impedance is an important key factor to decide. And based on that only, the IEEE 519 is also, it is giving the recommendations. Now it becomes standard. And as we last meeting, we discussed about 2-4 also, it is based on that. So here, let us see that. For example, I am having on 11 kV system, and fault level I am putting just the values. For example, 100 kVA, 100 MVA here, and 450 volt secondary, and transformer MVA is 1 MVA transformer. Impedance just I have given 4.5%. Distance of ACSR conductor is 5 kilometers, and the conductor resistance and reactance of the ACSR conductor I added here. I got that fault level here, the 14.42 MVA here, fault level. From this, I am here going to calculate the resonance frequency here. 14 MVA here, the resonance frequency. And I chosen, it is available in the website, free online calculator. I chosen this if you know the fault level. So here I am installing 600 kVA kVAR capacitor. The frequency it is 50 kVAR. Result is 241. See this 241 hertz. It is closer to fifth order. For example, if I reduce this to 500 kVAR, this may change. However, at the plus or minus close to the resonance frequency with this, every system, see, I am not considering any load here. I am not considering any non-linear, linear, nothing. only the resonance frequency, it is inherent property of any electrical system, which depends on the transformer capacity and the available ISC and the installed kVAR. It is automatically generated. See, everyone, we have the sinus, and whenever it is chronic, we are facing the problem. Like that, this electrical system also, it generates the resonance frequency. So we can see this is the dangerous one. All electrical engineer should understand how to calculate the resonance frequency, because of if they are, suppose for example, in the plant already there is 300 kVR only. So this is 341. It is, if they switch it on some capacitor or increase the capacitor, the seventh order can be reduced. So this is simple, no need of any filter. For example, if they wanted to add 100 kVR, 200 kVR, see this, 200 kVR I am adding. Now it is 500 kVR. The electrical engineer, electrician, whoever is using this, definitely it will be, it is going to be a fatal accident. Sometimes it can happen a fatal accident because of it is closer to the fifth order frequency. So all electrical engineers should understand how to calculate the resonance frequency. And in this scenario, if there is non-linear load, that is also, generating the fifth order harmonic, it is a serious consequence to the user, since it is a negative characteristics. So this is possibility of this resonance, we have to understand. And if anyone text me box, I will share the formula how to calculate everything.
That means in a short answer is, if you don't understand and take care of this problem, your capacitors can blast and it can create a serious issue.
Yes,
so
exactly.
Thank you very much, Mr. Reddy. The next question to Mr.
Once again, 20 years ago, this I faced the problem when switched on 400 kVR. It was very big flash. This is my personal hands-on experience. No?
Okay.
Okay.
Thank you, Mr. Ronak. Can you explain a case study of resonance and the heating issues at medium voltage MV power distribution and its ill effect on LV power distribution and mitigation measures?
Yes. So in continuation to what Ravi sir was explaining, now I will share my screen and just explain the actually where the problem was occurring. So
let's make it 3 minutes.
yeah. Yeah, so I don't know. I am not able to share my screen.
No, you can share. If you press the share screen, then you press share screen and you have to select the screen and share.
Yeah, just a minute. Sorry for the. Yeah. So now my screen is visible.
Yes.
Yeah. So here, if you see, like this is the typical power distribution scheme of the
full screen.
You
can make it. Sorry to interrupt. You can make it full screen. On the bottom, you can the bottom right side. Yeah.
So typical power distribution scheme, like for the heavy industry, where there is a testing facility where active front-end drive is used. You can see at the bottom, and 6 megawatt active front-end drive at the medium voltage level. Now this is fed by the again 7 MVA transformer. This drive was, due to some tuning issues, this drive was producing the distorted current, which we call it as a harmonics, right? Now this harmonics started traveling across the power distribution network, depends on the internal impedance of the circuit. But at the upstream side, at the main substation, you can see there are two installations of 600 kVR capacitor bank. One is here, one is here. And the symptom was, and the plant power was getting voltage was 33 kV at the input. So the symptom was the suddenly this 33 by 6.9 kV transformer. When first time this drive was switched on during the commission stage, during a fraction of seconds time, this transformer started making noise, and the noise value was somewhere around 110 to 120 dB. Actually, this was the first symptom when that was observed when the active front-end drive was on. And after some time, suddenly this 6.6 kV capacitor bank also got started hitting and making a tremendous noise because of maybe resonance phenomena. So at that, I mean, the client customer was not at all aware about, okay, what is this, what are the symptoms of this? And in fact, this drive was installed 500 meter away from that main substation where these issues were happening. So whether the problem is related to the tuning of the drive, because normally active front end drive is meant for the quality power, actually, harmonics free current and voltage. But here there was an issue with the tuning. And what could be the solution in that case? So filter or a choke at the input of drive, or any power factor compensation at the main substation, or remove the existing power factor compensation and replace with the passive harmonic filter. So client faced lots of issues during the testing of this drive. I will also present the summary of the measurement. So here there were very comprehensive power quality study was carried out with the different operation scenario, because this is the testing facility for the high speed rotors for the turbine and generator. So you cannot straight away go and achieve the speed of 3000 3000 rpm, 3600 rpm. You have to go gradually. So you have to fix the certain operation conditioning scenario during the harmonics measurement also. So when the drive was on and with the 600 kVr capacitor bank on and off, it is found that the resonance at 13th frequency component, the resonance study was also carried out. And if you see here at the 13th component, it found that, okay, there is a heavy resonance. So now at the 13th component, it is required to design the even filter or a choke to dampen this resonance and the nullify the problem. But here the problem was the cost aspects. I mean, why I am bringing this point is that many times many OEM, they take disadvantage of the end user and customer, that if they are not aware, and for just a 1 millihenry or 2 millihenry choke design, it was cost around 1.5 cr. Now management asked to prepare the various options, and finally the option solution what brought out is that remove the one existing capacitor bank and put the passive harmonic filter. And then during the measurement, 7th and 11th component was found high in a higher harmonics. So for 7th and 11th frequency component, passive harmonic filter was installed in place of this capacitor bank, and just in around 65 lakhs the solution was brought out. So my point is that such kind of issues, even because of this AFE drive, and this is a classic issue only because of the resonance. So Mr. Ravi sir can put more emphasis on this. So this was the very classic study which was performed. Thank you.
Thank you, Mr. Ronak. Thank you, Mr. Ronak. It was a nice explanation. Now the one more question to Dr. Shilguri. Dr. Shilguri, you can can you explain the challenges in implementing solutions for power factor and PF and automatic power factor? Sorry, APF.
Yeah, actually, I think in the just the previous case, it was a very nice scenario where one has to look into it. We have to understand that there are two types of solutions available for harmonics. One is passive filter, another is active filter. Now we have to understand these are customer side solution. Okay, so now the customer side, the harmonics are fixed harmonic or variable harmonic, but we have to decide first. If it is a fixed harmonic, then we can install and passive filter and solve the problem. But if it is a the load is varying and the harmonics are also varying, that means that sometimes the third harmonic is high, sometimes fifth harmonic high, sometimes seventh harmonic high. Then actually you cannot install passive filter. You have to go to the active filter. Now you have to understand active filter itself has electronic component and it can generate some other issues. That one has to be careful. That means you can use active filter, but you have to use properly. Otherwise, it will create some other problem. That is what it was highlighted in the paper that I showed earlier. So, like somebody also mentioned in the chart box, LEDs are emitting harmonics, very higher order. But everybody is using LED for energy efficiency purpose. So we do not have any sudden solution. So what we need to do is we need to be carefully design LV distribution, keeping it in the harmonics in the mind. So that is the one solution. And here that particular drive is actually creating problem. So whatever the solution, it has to be near that load only. And one more question I want to answer is that the current harmonics are produced by customer only, but the harmonic pollution is moving upstream is voltage. So you have to understand that if you provide a solution at the customer side, you will not propagate voltage pollution to the upstream and create problem to the other. So that is my answer. But final conclusion is that one has to do the PQ monitoring study and take the expert advice in this case.
Thank you. Thank you very much. Now the next question was a detailed answer. Now the next question is, what if voltage harmonics are not complying to limits? Question to Mr. Haribala.
Voltage harmonics non-compliance generally comes, voltage is the responsibility of the utility or the DISCOM. So in this case, we need to prove at least by switching off our loads and say that voltage VTHD is higher, which is coming from the distributor side. That's point number one. Point number two, if there is an issue with the voltage total harmonic distortion or the voltage individual harmonics, it needs to be appropriately informed to the people in the distribution company so that they should work on it. Because as IEEE 519 clearly states, it's the responsibility of the utility or the operator who provides the power supply there at the point of common coupling. So they may have to do some change of impedance or whatnot to ensure that the quality of the power what they give. Ideally speaking, in any of the generators, when generated, it is a pure sine wave. But over a period with so many loads getting added up, and then this, there is a change in the waveform of the voltage, maybe because of the other consumers who are throwing harmonics into the system. As professor said, right now it is going upstream. The voltage is going upstream on voltage harmonic is going upstream. This upstream from some other customer is a downstream for us, whoever is actually doing it. So it needs to be appropriately handled. So that's what I would say here.
Thank you, Mr. Hari. Ravichandran sir, now the question to you. What is your opinion on active harmonic filters?
Yeah. The active harmonic filters is a evolved technology, but to my opinion, I have a difference in opinion with Professor Chalkuri because of the IEEE 519 is based on at PCC. They are allowing, depends on the short circuit current level, they are allowing the harmonic distortion up to certain extent. No need of any control. And another one thing, either active or passive, if it is oversized only by seeing the TSDI, it is going to increase the impedance and there will be a negative worsen the system. So it has to be appropriately sized. And if you consider the passive filter as a tuned one, definitely it is a problematic one because of tuned to the particular frequency. But if we are designing the wide spectrum broadband filters, the filter can swipe in all the harmonic frequency from 5th, 7th, 9th, and 11th, like that. So passive filter also high performance and at any variable, highly dynamic load also, that can be designed accordingly. And here induction furnaces, many furnaces up to 3000 kilowatt installed passive filters, and it is performing well. And the active filter is a solution for the off the shelf available solution, but it creates, as Dr. Chilikri said, it creates the supraharmonic, and we never addressed this issue. Secondly, since active filter is installed at the LV side of the distribution system, and the harmonic frequency that inject the negative sequence harmonic frequency, that will enter into the source only. So if you consider this load side, the harmonic distortion, the same what you before the filtering, there will be no change. So the purpose of filter, one active filter, is the compliance requirement. It is installed. If you want to the real mitigation, active filter is not going to solve your issue. And also see this readings also it is proven. So active filter, unless it is installed at the load end, it is not going to solve the issue. But installing at the load end, it is expensive. So passive wave filter is a wonderful performance if anyone design the filter properly. Secondly, active filter is working principle of the active filter is based on the CTs what we are using. The CT, market available CT, is it possible to get the frequency bandwidth above 500 Hertz? It is a limited bandwidth. So active filter is working for targeting up to 2.5 kilohertz. How this can give the performance to you? Secondly, the power consumption also it is too high because of minimum 2.53 kilowatt it needs power, and per day you can calculate that. So passive filter is very low, and since IEEE 519 is applicable at the PCC, I don't think if you limit the resonance due to the capacitor by adding the series reactor with the appropriate linearity, that can solve most of the issues. And I don't think very simple approach. Only unless we have the problem within the LV network, we have to address the issue. And for the compliance monitoring, it is IEEE 519 is comfort to any consumer. No need of worrying about the harmonic, since no one should worry about the THD. By seeing the TDDI, it is very comfort, and no need of any anxiety or panic about the harmonic. It can be simply solved.
Yeah, thank you, sir. Can you throw some light on this detuned filter and how to check the healthiness of detuned filters at the site?
Yeah, detuned filter, that performance, detuned filter performance is what we are switching off the bare capacitor. Whenever we are
Now you can continue, please.
Oh, okay. See, if we are switching off the reactive power system within the system, what is the harmonic level? We are able to see the parameter. If you switch it on the detuned filter reactor bank, if there is no change, the same, because of before installation of the detuned filters, if there is when with bare capacitor, if it is, for example, if it is 30% or 40% harmonic, after switching it off the capacitor, it drops down to 10 or 12% like that. So we have to design the detuned filter to completely eliminate the resonance due to the capacitors. This is the performance, first level performance. On the other hand, after installation of the filter, if the linearity is not appropriate, because of absolute current is the main criteria to design the filters. If it is not appropriate, this resonance may not be filtered or attenuated by the detuned filters. On detuned filter is called the blocking reactors. Okay, it will not filter harmonic exactly. If the linearity is not appropriate, that harmonic level may be elevated. And sometimes, the harmonic amplification also, you can see that it is prone when we use the detuned reactor. And secondly, detuned reactor has to be, I am showing one of the screen here. This is the important factor we have to find. Linearity. See, detuned filter, for example, we are the when designing 525 volt capacitor we are using for the system design, and the capacitor rating is 33 kVR. It will give 25 kVR delivery, including the 7%. 7% is 189 hertz. I am using the common reactor what everywhere it is using. So this is going to give you the 189 hertz frequency. This is a 7% reactor. Okay, only with the millihenry of the reactor and this microfarad, these two parameters are more than enough to decide the 7%. But the current handling capacity of the reactor, no one is worrying because of linearity. The standard reactor, it is 1.6 and or 1.8 only it is available in the market. Linearity is the important key factor. This individual order harmonic component, I am here. See this, fundamental is 100 ampere. I am putting 30 ampere here. And seventh is, for example, here 15 ampere. Ninth is 5 ampere, like that I am putting. I am adding all the values here. The linearity, it comes 2.52. In this location, if I use linearity designed for 1.8, so definitely the reactor, the detuned filter entirely the system will fail. Or immediately it is not possible to say that passive filter it is not worthy for the installation. So the design is important. This only by seeing the detuning frequency and the 7%, no one should immediately it is not possible to use off the shelf what it is available.
Sir, one quick, I would like probably one quick answer. In the market, we can see a lot of companies are selling this 7% detuned filter. Is it really a good solution or just, like a screwdriver solution?
Yeah, that's a screwdriver solution, to my opinion. See this, as I told you, the fundamental current already I explained to you, and here, the Ronak here given the excellent case study here. Okay, the fundamental, unless we understand the fundamental current here, what I have seen here, the absolute value
Yes.
of harmonic and the individual
Thank you.
here,
Sir,
the
thank you.
design
You answered my question.
unless the linearity is appropriately designed, the market available reactor probably, it may
So
end up.
basically, it's a screwdriver solution. That is what you say. It's a screwdriver solution. Thank you. Thank you very much. So actually, in a webinar, if we try to explain too much technical, since the viewers are only seeing the screen and listening to the voice, it may not be understandable to the viewers. So it would be the best way is to make with quick answers so that it is more easy for them to act. So basically, this detuned filter is like a screwdriver solution, not the proper solution, appropriate solution. Now I have one more question to Mr. Haribala. Is it not enough to do power quality audit every year to check compliance to IEEE limits, IEEE 59 limits?
It is not enough because it is a continuous process. The whole grid always changes, is dynamic. The load changes or dynamic. So in this situation, it is better advisable to have a complete study at one point in your plant where you see there are a lot of harmonics. It is always a continuous readings of the data would always help in the long run. Having said that, the PQ audits for a we is like you get an expert, give them a solution. As long as you are implementing the suggestions given by the auditor, then it will add value. But if you are only taking the audit, putting it in the file and giving it is not going to help. So this is what usually happens in many of the organizations and industries here. There is a study taken, but there is nothing implemented afterwards. So it's for that sake, at least we need to have a continuous monitoring. Even it will help the experts to give a better clear-cut answer to the solutions as well. So I would always recommend continuous monitoring.
Okay, thank you very much. Actually, I would rather, I often say, probably sometimes people don't like my comments. I often rather say, we use the cheap quality products, not the appropriate product, which is producing more garbage, and more garbage is more business for everybody, and all are happy. So it would be great if participants have some questions. If you can raise your hand, we can unmute yourself and you can ask your questions directly to the panelist. We have some more questions in the chat box. Let me select one of the questions. Mr. Rajendra More, can harmonic have any effect on DG load? In one of the case, DG is tripping at 60-65% load due to harmonics, and oh, suddenly what happened to the question? I think somebody answered the question directly. Thank you. So, Mr. Panir Selvam, question to Mr. Ravichandran. When the resource frequency is highly dependent on the short circuit level, how to arrive at the fault level of a consumer premise and how far it's a reliable data?
Yeah, excellent question. Appos are also explained about this. The fault level at the substation, it is every once in 2 years, the state load dispatch center, they are releasing that. And up to 110 kV. The 110 kV, 230 kV, this system level, once in 2 years, they are releasing. And afterwards, the MRT division of that utility company, they have to calculate and share the detail at 11, 20 to 33 kV to all the consumer. And suppose they should fix the board also. What is the available short circuit level? And the consultant here for the new project, they also start from the when it is greenfield project, they have to consider the available short circuit after adding including the impedance of the ACSR conductor. But unfortunately, TANGETCO is keeping the data as a confidential thing, and it has to be shared to the consumer, and it is not confidential. From that, it can be arrived. And what the transformer we have, we know that we can include that impedance, and the LV side we can arrive the short circuit level available at the 415 volt. So it is a methodology I am following.
Thank you. We have one gentleman raised the hand, 2-3 are there, but Mr. Srinivasan, you can unmute yourself and ask the question. But before that, I would like to take one question from Mr. Panir Selvam. Question is to Apav sir. What is the procedure approved for arriving the short circuit level of a customer? Where the short circuit level of feeding substation to be taken as the short circuit level of the to be arrived at the as that will be the factory site, as it will be vary from customer to customer. What is being adopted at present and authority to use it? I think the question is not exactly related to the today's subject, but probably, sir, if you can make a quick answer, would be great.
Yes. I would like to answer this. Actually, the short circuit level is determined for the purpose of implementation at the SS level. The substation level, the implementers are determining the short circuit level. You have to consider that short circuit level only for the purpose of mitigation against the harmonics emission into the grid. For your own internal purpose, you have to arrive it based on the actual, you have to get the data from the concerned DISCOM people, then arrive at the downstream resistive and impedance things, then your own source, the transformer, up to the final load. There, what is the impedance? That only, from that only you can arrive at the actual compensation at the end use. So the two things, for the purpose of mitigation with the compliance of harmonics, if at all anything existing in your area, because only 2 states have regulatory commissions have arrived at the notified the things. That is one TNRC and Tamil Nadu and Maharashtra. With the remaining states, there is no such orders as of now. So I hope I would have answered your question.
Thank you, sir. Thank you, sir. Mr. Srinivasan, you can ask the question and you can discuss.
It's not a question. Actually, what I am telling, Mr. Kobaguma sir, you are fighting for the harmonics like this. Why don't you ask a manufacturer to implement how this much of the harmony should be your product should be within the limit of this harmonics. Why don't you make IS for that?
Yes, actually, this is what the question I am also asking always to myself. Now, in the screen, what you are seeing, probably, Hari sir, if you can explain this particular thing from 61,000 to 4, would be.
Instead of going the long process to curtail harmonics, so many things, active filter, passive filter, like that. So this you have to study for that is what is the tangent code is not giving this much of a what's a circuit level like that. Why don't you? I have seen some of the product in foreign products. They clearly indicated that the harmonic limit is less than 5%, less than 4%, like that. Why don't you implement this in our country?
Correct, sir.
You can suggest that the IS, we have to make IS, that all the products from the VFD, everything. Suppose I have seen some VFDs, that is Atlas Copco VFD, it is 65% because the cost.
Oh my God.
So,
right, sir. This is
65%,
what,
we have to fight for, I have to spend
Let me-
around 2 lakhs.
Sir, this
Let
is
me
what
explain
last
you.
time also we discussed. This is what last time Mr. Hari told in Europe as well as in Gulf countries. The amount of harmonics which is or this amount of this garbage produced by the electrical items are limited. Now I have shared the screen. Probably Mr. Hari, if you answer, would be great.
Yeah. For every device which can generate is there are always a standard that they should emit, but there is also a condition behind it where they are placed, what is the loading and stuff like that. Say for example, you use a very good VFD and you are loading it only always 50% or 70% of the time, less than 20% of the loading on the VFD, then naturally the total harmonic distortion would be much more higher what is then actually planned for in the VFD. So it depends on from the choice and selection of the ratings. It depends on the choice and selection of the location where you are installing these devices. Suppose you are in a place where you have a very weak grid, then naturally you are not you are not eligible to throw more harmonics, in other words. So it is very, very difficult to put a very fixed standard or a quantity by saying this is the limit and no equipment should cross this. It is very, very difficult because everything world around the load is very, very highly dynamic. So in that possible, there is some standards like 61000-2-4 gives these kind of equipment, how these equipment should be behaving with for giving out harmonics. It is not that every grid and every regulation gives us some kind of a liberty to throw harmonics into the system, but how much you throw makes the difference, and from where you are throwing makes the difference. I think other people will also agree with me on this, but it depends on that. So your idea of keeping one limit is very, very good, but it is not practically would be possible, is what is my point.
But what about the fixed load, such as let us say LED lights, computer power supplies, and small SMPS power supplies? Let us leave the large load. But what about the fixed loads?
Fixed loads, we should have proper clear-cut information. I don't think we still have an IS for that, how much of harmonics an LED lamp can throw.
So that means an area where which we can work out is we have to work with BIS first to make adopt this particular standard or maybe
Very
make
similar.
a standard, then go to CEA and ask CEA to implement it so that the manufacturers or make a BIS certification that only, for example, LED lights, only you comply, then you can sell in the market. This would be the better, probably the better way to handle the situation. Will it be appropriate, Mr. Hari?
Yes, that's correct. What you say is absolutely right. Yeah.
Thank you, Mr. Srinivasan, for the question. So we have to actually, stop the disease, and then only we'll be able to get a good solution. We have Mr. Avish.
Mr. Gopal, since you are working with the VAS committee, my sincere recommendation is 61000 3K2 addresses up to 16 ampere single phase loads. So 3-12 addresses the 75 up to 75 ampere load. So if we don't have standard here for that individual loads, and as Mr. Srinivasan asked correctly, 2-4 is the feeder level monitoring. And if you are going into the equipment level standards, we can abide with that and amend with the BA standard. That will be helpful to us for the individual equipment.
Sir, can you tell the maybe the table number so that I can show it on the screen? You are seeing 61,003-2 on the screen.
Yeah, 3-2. That is also nearly following the 2-4. What Hari is
Okay.
up to
What
16
about this one, the 3-12?
12 is
Limits it is
above
16.
16 and up to 75 ampere load.
So that means there are already standards available. Only thing is it has to be adopted to India and the people should follow.
Yes. Yeah.
If these standards are followed, it will be equal to any other developed.
But one thing, this is also based on the ISC. So if we are discussing about this
Short circuit.
Thank you for the answers. Now we have one more hand raised, Mr. Davis. Mr. Davis, you can ask your question to the panelists. You have to unmute yourself.
I answered. That's why I raised the hand. I don't have.
Mr. Davis, you have unmute yourself and ask the question. If there is no question.
Is it audible now?
Yes,
sir?
Yes.
Okay, thank you, sir. So I have two questions. One question to Mr. Ronak Desai. You have given a case study, and this is related to that case study. It's a steel plant background, rolling mill and coil box and then galvanizing. So there are a lot of VFD drives comes into picture. Now, in steel plant, generally we see the static war compensation. SVCs are also installed. So, how these SVCs and harmonics, how can you throw some light on this? Why?
Sir,
and this is installed at
whom, sir?
Mr. Ronak Desai.
Okay, Mr. Ronak. Hope the question is clear to you. You have to unmute.
Yeah, so SVC is of course one of the compensation, especially for the steel plant and for the arc furnaces, right? So it takes care mostly for the voltage control, power factor compensation. But yes, of course, the harmonics component also can be taken care through the SVC design. Only thing is that the design, as explained by Ravi sir, the design aspects of SVC has to be taken care with the proper measurements of the harmonics components generated from the end equipment.
Okay. Thank you. And
thank you.
My next question I have one more question, if allow me for 1 minute.
Make it quick, please.
Yeah, this is to pause. Now, after hearing all this, all the insights from all your experts, now my neighbor is going to install a solar rooftop and EV charging, and I am in an apartment. Now, how is it going to affect my home appliances? I think it's a question to pause and earthing. So, yeah.
Okay. See, you have to go through chapter 11 of CEA regulations. Regarding safety measures, they have clearly spelled out the regulations under chapter 11. You can see all the basic things of NEC code and the regulations are quoted therein. One important thing what I can say is, with regard to the earth leakage and other things, the residual current. Here also they have furnished one stipulation that RCD should be monitored. RCD should be provided. So here what I can suggest is, there could be some DC, smooth residual DC components also. What type of RCD you have to provide is more important. See, regulation does not go into the details. Since you are interested in your own safety, it's a must that you choose a right type of RCD That is class B, type B alone will these purposes. EV chargers, a combination of solar, rooftop, everything. And moreover, there is no regulation prohibiting availing connection from the what do you call this, a distribution company quoting, because there is no BA standard, there is no quality control order restricting the flow, as Mr. Ayyappan Srinivasan told. So these are the things yet to come. Once it is not sufficient to have a BAS for the product, you should be notified under the quality control order. So till this time, you have to ensure that whether you are providing a mitigation against the electrical parameters like overload, short circuit, and leakage, that is already prescribed under NEC. You can go through that. That's all.
Thank you, sir. Thank you. Thank you, sir. We will take two more questions. We have Mr. Alwar Purushottam. If you have question, please unmute yourself and ask the question. We have also Mr. Ravichandra Mehta. Probably one of you can ask the question. You have to unmute yourself and talk. There is no question from your side. Now, Ms. Rajeshwari, you have raised your hand. If you have question, please ask the question.
Sir, can you hear me?
Yes.
Yes, sir. Actually, my question is, when doing the harmonic study, so why we have to switch off the capacitor bank for 5 minutes? So there is any reason for that?
The question is, when we do a harmonic study, why the capacitor bank is switched off? That is the question. Am I correct?
Yes, sir.
Yeah, probably maybe I can answer in a very simple.
Yes, please.
Yeah, so basically, see, we have to see the harmonics generated from the source, I mean, from the load side, and which will travel to the main bus, right, up to the source. And if probably if at that point the capacitor bank is installed, capacitor has always a tendency to amplify the existing harmonics into the system, right? So when we do the power quality study, two scenarios are very important. With the switch off, I mean capacitor bank switch off condition, you have to measure for the certain duration, and during the switch on, so that you can get the better picture that the harmonics which is generated from the load side, if they are getting amplified at the main bus or not due to the existing capacitor bank. So this is the only purpose to check the to do the study of harmonics to the two scenario. One is with the capacitor bank off and another is with the on condition, so that it will give you the complete picture. Thank you.
Hello.
Thank you. Thank you. Thank you. Thank you. Mr. Ravichandra Mehta,
Yeah.
please.
Good afternoon, sir. The expert, I think all are agree with that. There should be a continuous monitoring of harmonics. So in that case, Syed and Sigre has found a committee, JWG C442, where the main subject was the continuous assessment of the harmonics at consumer level. In that, I was privileged to say that I was the member of that committee, and it was suggested from our side that in many of the utilities in India, particularly in Gujarat, they have the energy meters that have the feature to monitor the harmonics, and accordingly they load this content with the tariff part of itself, so that the customer will be will getting the will have to pay more if they emits the harmonics. So I want to ask whether this is feasible or not.
Don't know to whom I can post the question. Probably one of the panelists. Dr. Shilgiri?
Okay, my suggestion is that harmonic measurement and also power quality has to be continuous for, especially for the customer. And the reason being is whether these harmonic and disturbances, whether they are well within the limit or not. Okay, if they are well within the limit, he is safe from the problems and also any penalty. But
Yeah.
if they are not safe and they are above the limit, then he don't need to wait for equipment to fail. So this is the main reason I was suggesting that to continuous power quality monitoring, not from the grid point of view, but from the customer point of view. Because customer, he will be spending only small amount of money for PQ monitoring and PQ audit. But whereas if he is going to spend money on the failure of the equipment and then the shutdown of the plant and doing the repair and all these things due to PQ, that will be more expensive than doing the PQ audit and solving the problem. So this continuous monitoring is going to come in future, and but it's going to fall on the customer responsibility, not on the grid. Grid also, this IEEE standard recommendation of 1 week monitoring power quality will not solve any issue. So this is my observation that IEEE and IEC, they have to change their practice. PQ audit 1 week is fine, but any solar plant or wind plant, it will not exhibit repeated pattern of 1 week throughout the year. And if you want to investigate any grid related problems in the smart grid due to increased level of distributed generation, continuous power monitoring has to be done, and it is important for both the grid side and as also the customer side.
Yes, yes. Yes.
Thank you, sir. Thanks for the question. We have allowed.
Just I want to add one more point
the-
to Mehta sir as question that even CEA has mentioned about the continuous monitoring, right, for 33 kV and below. So IEC 61000-4-30 Class A compliance. I mean, we need to check. I mean, these energy meters, whether they comply or not, right? So of course, the power quality meter, the purpose and the compliance to this IEC 61000-4-30 is again the which is very different from what the energy meter can do. And another is the sampling rate, because here when we have to analyze the events of the voltage or a current, then sampling rate of the power quality meter are quite better than the energy meter. So this is
that, I think centralized there is a need.
This one.
Thank you.
As Chilpuri said, it is continuous monitoring is required, and properly this Ronak ji given that the CEA has CEA amendment, it requires the continuous monitoring, and the data has to be shared by the consumers to the utility company. But on the other hand, utility company has to share the data to the consumers. But this is not, in between, the bridging is not properly done. And secondly, the energy meter is the revenue meter. That is not clubbed with the power quality meter. Power quality needs entirely different, technology and needs more, as Dr. Chilikri said, we have to update. Still, we are, facing the challenges in implementing the existing very simple standard. IEEE 519 is very, very simple. Anyone can follow, but the utility company is facing the challenges with this present, the basic standard. In this case, how we are going to address the supra-harmonic, we don't know. In this case, energy meter, clubbing the energy meter and power quality is really a complex situation, and in India, it is impossible to achieve this type of if we have this system, and it is very difficult to achieve the power quality standards.
Thank you, sir. So basically, the problem is it is not only the scope of the discussion is not only limited to harmonics. It is a much bigger issue which probably the whole world is going to face in the future, and especially as the largest producer and consumer of the major power consumer, India has to spend a lot of time, a lot of research, and find out proper solutions for such issues. Otherwise, the reliability of our electrical installation will be going down, and unnecessarily we will be ending up with trouble. Now we go to the last question from Mr. Ramesh Suryavanshi, the last question and the final question. Thank you very much for all the panelists. Mr. Ramesh?
Yeah, can you hear me? I'm audible?
Yes.
Good. first of all, there is no question. Of course, I carry out a lot of harmonic system studies internationally, and I have not found any difficulties in this. I have connected Kuwait, Qatar, Bahrain, and Saudi Arabia 50 to 60 hertz, getting the RX plot and getting the impedance of the total countries and designing the harmonics in different countries. We have done it. But let me first thank Gopa Kumar for arranging this kind of seminar. And of course, all thanks goes to all experts who are given this kind of expert talk on harmonics and given the awareness for the people. What I can see, there is a lack of system studies. And of course, harmonics is definitely, there are many other things, system studies to be carried out. We completed many oil and gas complex system, even steel plant, but lot of system studies we carry out. We take nearly 9 months to 12 months to complete the things, and we see that no trouble is problem. But I get a lot of case studies from Kuwait Energy, Qatar, cables is heating, transformer is heating, a lot of other things, because the consultants are not carrying out complete system studies. There are a lot of things, and we have to update it. If the system is changing, you can't help it. You have to update your harmonic. Nothing. I like to get in contact with all these expert talks, and I have published a lot of IEEE on harmonics paper. So, and I'm working with IEEE working group and producing the standards loads behind meters. I'm a secretary for that. I would like to get contact with each and every. Of course, I have got in contact with Chilukari, but not Ronak, Balasubramaniam, that I could see that a lot of good things, system studies are given, and expert talk. Let us talk together and help the society, which I do. Thank you, Gopa.
Thank you, sir. Thank you, sir. I hope you are also a member of NFE. If you are not a member of NFE, I would request to become a member of NFE. We can probably make a group within NFE for handling this particular project. We can also get support from several organizations, national as well as international, and we can take up the subject in a much better way. Thanks for Ramesh sir to participate in the.
Gopa, let me add. I'm blessed by Dr. Jose Arilaga, the best harmonics power quality books written on earth. He's from Canterbury University and HVDC. And of course, I work very closely with SIGRE people, and SIGRE documents are the best. So, of course, as you said, let us be a member of NFC. I would like to, and help the society. What is I see in India, presently I'm a global director, and connecting UK to Scotland with renewable energy, HVDC, and now also working with Siemens synchronous condenser to provide the grid stability and go to national grid for compliance, UK. So this, let us help this. And in the group, as Gopa said, I have met Gopa in one of the conference in last year in November. But anyway, I will become a member, and I would like to get in connected with Ravichandra and Ronak and Aparva and Balasubramaniam and Chilukari. I got in contact. Please share your contact. I will give my contact number. So let us do that, sir. You are all experts. Let us contribute to make it better India. Keep the lights, keep the electricity flowing, and keep the lights on.
Thank you very much, sir. I will send you those contacts. So please try to become a member. We also allowed the name Mrs. Rajeshwari to allow. She was allowed to speak, I think, but I can't see the mic. That means probably there is a connection problem. Sorry, madam. It's not a problem from our side. So with this, we are completing almost 1 hour 50 minutes of our webinar. Normally, the best time for making a webinar is 90 minutes. 1 hour 30 minutes is the best time, but we have crossed the time. But it was quite interesting that the discussion went very well. Probably if any of the participants or if any of the panelists wanted to make a conclusion, probably you are welcome.
Gopal, you conducted very well this seminar. Thanks a lot. And the speakers have added very valuable solutions there and valuable discussion. Thank you.
Thank you very much, sir. Also, thanks for all the participants to participate in the webinar. Our second webinar on harmonics. Probably we will make one more, which is focusing on the mitigation techniques, the mitigation methods or techniques. Probably we will come back to you in a week's time with the next program. Probably it may not happen the coming week, or maybe within 15 days we can make it. If there is no questions or comments further from the panelists, not from the participants, panelists, probably we can close the session. I hope
Yes.
all of you agree.
Thank you.
Fine, sir. Thank you.
Thank you very much. Thanks to all. The video in our YouTube link probably in another 2-3 hours. We request you to go through the YouTube link, and probably if you can post the questions there, experts can also make answers.